Hello again, YouTube, and welcome to yet another unedited, unscripted, raw, naked video from deep within the bowels of Dr. Jet's laboratory, where we are building the Dona Outrigger. Well, we're getting real close now. We've got our ride pads on. We've got our leading edges sanded smooth. I've installed threaded aluminum rods here to hold the turn fin. I did not like the turn fin mount that came with the kit. It seems kind of wimpy, and there's a lot of loads on this. If you read the KEP's direction, they want you to use a kind of beefy piece. So I used this piece of carbon fiber, and I drilled and tapped it here so I could move my turn fin back and forth. Another thing here they do in the KEP's rigger is, because of prop walk, these things want to walk the rear end to, what would that be, the left, and turning the boat to the right. And so to counteract that in the straights, they'll actually cant this in 1/8 of an inch, essentially turning this turn fin. I can accomplish the same thing by just putting a washer in here and canting the turn fin. Additionally, to counteract that prop walk, I've moved the tub 2/10 of an inch off the center line, although I can change that at will at any time. When I put the sponsons on, we'll talk about that. So there you go. So on the building board, I've added some blocks to index everything. And so I'm going to show you what you want to achieve with this entire setup. So you want to be able to put the tub in here, and you see how it rocks a little bit. So I put a little weight there, and these Delrin blocks I get from eBay for sanding blocks, I'm just going to slide it under there to where it just barely touches. And because this tub is twisted, this isn't totally perpendicular right there, but that's sort of holding it right there. So that's pretty square. Then, of course, the sponsons will go in, indexed properly. And same with this one. And what you will want to achieve is this. When these are all connected, you don't want any twisting anything in that. You want them just to be exactly right. And so you want to be able to take this rod when everything's all copacetic and just slide it in like that. And same thing with this one. I noticed a little friction in there, something exactly 100% on. I may have this off just a taste there. Yeah, and you want these just so they'll slip in and out. That way, you know everything's going to be square. Eventually, I'll take tape and tape these up. The Japanese are doing that. The Europeans are still drilling and putting pins through here. I don't like that because drilling weakens everything and it forces you to be right there. Remember I said I moved this off by 2/10 of an inch. So I can always move it back just by moving this and taping it up in a different location. So there's that. The rudder. I think I'm going to use this style rudder. And there's a couple of things I don't like about this style rudder, but you can get around it. When you get it from the factory, you notice it's sloppy. Look at how much slop that has. It's just sloppy. And the slop is right here in this arm. You see it tightens up against the pivot pin. So the arm is tight on the pivot pin, but this whole bracket that holds the rudder is just sitting on this arm. It's not really attached to anything. So I take some blue Loctite and just put a couple dabs of blue Loctite around there, work it in a little bit, and it's much tighter. Now, if you ever need to get it off, because it's the blue sauce, you just, and it'll come off. So that's that. Now, here's it. My plan was to use this rudder, but you notice it's going to be really close to the propeller here. So at first I thought about milling the edge of this at an angle, so this would mount at an angle, but then it would ruin this bracket, and if I stole it off of this and wanted to put it on another boat, I couldn't. So I think I'm just going to take this little piece of Delrin, drill holes in it to fit, and the way these mount is the screws go in from behind, and then I'll just mill this off at a bevel, and so I'll bolt this in at an angle. I may even go so far as to take a little carbon fiber plate so that the heads of the bolts will be perpendicular to a surface where they're clamping this on, and I'm going to run the rudder off to the side like that. There you go. I'm going to use a ball joint here. I'll have to ream this hole a little larger so that'll go down in there. And then I'll use a real short piece of this 7mm tubing, just enough that I can slip this bellows over it. And then because of the angles of dangles, I'm going to have to put a 90-degree in here, and that's where it will actuate. That way I can clear everything here, but it means I can't do my adjustment for throw there. I'll have to do it at this end, which means when I finally establish this bend, it's going to have to be pretty much perfect. I may make this a 45-degree bend, and that way it'll give me some flexibility. We'll see. So there's that. We've talked about this. We've talked about this. My wonderful little sanding blocks. The strut will be up at 6mm, and it just happens to be a 1/16 of an inch higher than the board. So I'll put a 1/16 of an inch shim, and that will be my propeller height. And so this Teflon tube will go into the nose cone here. This will go into here, and between here and here, I'll put a piece of shrink tube. And that will be the setup. So the next video, we'll put in the motor, we'll put in the drive line, we'll get everything squared up and ready to go, and then it's out to the pond. Okay, that's it for this video. We'll see you on the next one.